So yeah, today I'm going to talk about Scala Async, and both the project as well as a good chunk of the slides is actually joint work with Jason Zaug, my colleague at Typesafe. So that's essentially our project that aims to do what actually C# and F# have been pretty good at, in our opinion. And I must say that, so I've been working on a bunch of async and concurrent programming models in the past with like actors, join patterns, futures, and so forth. But it's kind of like this Scala Async and things like the F# async workflows, C# async. Like there is something about these models where they hit a nice sweet spot, in my opinion. And I'm going to try and convey this in this talk a little bit. Because for asynchronous programming, there's a whole bunch of programming models that are out there and try to simplify things. But I feel like every one of these models at some point hits a wall because you always have to somehow manage suspension, resumption, responding to incoming events and so forth. And if you don't get at least some support from either the compiler or some macro or a way that sort of can transform your code, it's always going to be difficult in some way. And so async is really, it's a very nice project in the sense that I think it can help you really simplify your async code. So what's the problem? Well, actually, the previous talk here on reactive extensions actually had a good intro to this. Basically, we have all these events coming into our apps, and like if you want to write a responsive web application, you need to use some sort of async programming. And there's a bunch of programming models. They each have their strengths and best sort of killer apps, right? There's actors, which are extremely good at messaging, remoting clustering, fault tolerance, right? Encapsulation, so forth, isolation. But there's also futures, right? For example, also in C# you use tasks a lot. In Scala we have, now in Scala 2.10 we finally have a nice futures and promises library that I've also been involved with. And so these are sort of extremely important libraries, essentially, but they can still be hard to use, no matter how hard we try to come up with nice APIs, right? The other thing is, if you want to make sure your app scales and is high performance, you need to use, at the lowest level, you need to use things like non-blocking primitives like compare and swap and all these things, right, on the lowest level. But building on top of these things, your code tends to become unnatural, right? That's it's sort of it's art, right? It's the art of multiprocessor programming, right? So, and with async, we're sort of trying to make it so that your code becomes much more natural, while at the same time using sort of the best, most efficient non-blocking APIs under the hood. So, and again, our inspiration actually comes from C# and F#. So C# 5.0 introduced async and await that actually was also mentioned in the previous talk. And we don't claim that we're sort of heavily innovating on the programming model, because it's actually a pretty good one, done by an amazing team that's been doing really, really great stuff with it. And I've really been happy that I, been talking to people involved with this on and off. And so we're sort of avoiding NIH, which is can be a good thing, right? But of course, we also have our own twist to these things, which makes it quite interesting, especially towards the end of the talk. I'm going to show you some things that are enabled by our approach, which is basically we're not building it into the language, right? We didn't extend Scala, the language. It's not built into the compiler. Instead, what we're providing is a macro library. So macros are quite a new feature of Scala. It's an experimental feature of Scala 2.10, and it's still sort of incubating, right? So there's work being done on what's supposed to become the stable version of macros at some point. But it's very usable today, and there's an amazing number of applications for those things. And for us, really using this macro facility had a lot of advantages, right? On the one hand, we can actually ship a stable implementation that works not only for the upcoming Scala 2.11, but it also works for Scala 2.10. So you can actually try it out today. You can even, if you're confident, you can use it as is, right? And the other aspect is, besides the sort of simplified packaging of our async module, the other aspect is it's more easy to extend and adapt, given that it's just a macro library. And I'm going to tell you a little bit about some experiments that we've been doing that actually tie into the reactive extensions that Donna and Matt have been talking right before this talk. So this talk is going to be very short. I've only got 3 bullet points here. So I'm going to have lots of time for questions. Just kidding. Never works for me. So basically, gentle intro to async. You really only need to know two constructs. One is called async. You open a block, put an expression in there, and it just declares this expression to be asynchronous. And in fact, even though by default this is going to be executed asynchronously on a pool thread somewhere, that's just the default. You can customize the execution thanks to what we call execution contexts that we've introduced in Scala 2.10 that we use for futures, parallel collections, actors, and so forth. They all run on an execution context, and you can plug in any one of those here as well. So what you get back here from this async block is a future. And again, futures are very similar to tasks in F#. But futures and promises are extremely popular in most languages nowadays. So if you haven't looked into those, I encourage you to do that. So how can we use this? Well, you can use async just for spawning off some async activity if you want to. So the simplest case is just to wrap some computation that you want done asynchronously in an async block. But of course, more common is probably that you get some result back, and so then you get back a future for the result that's then going to be completed at some point in the future. And but what you can also do is you can just, if you have a method that should basically run asynchronously, right? You can return a future, and then you just put the entire method body into this async. You just put the entire method body into this async, right? And this is basically, well, essentially it's an async method, right? In Scala, we don't have, or we didn't introduce asynchronous methods. In C# they do, right? In C#, async is actually a modifier on method declarations. But for us, for us, we can use it as a convention. It reads quite nicely, so why not? Now, the second thing you need to know is await. And await is basically something that allows you to await the result of a future. So you use it inside async, and the cool thing is that you're waiting for the result of a future, but in a non-blocking way. So you can use await as much as you want inside your async block without any regret or bad feelings, right? Because it's the async macro is going to take care of transforming your code so that await just registers an on-completion handler on your future. Yeah, so await takes an expression that evaluates to a future, right? And it just registers an on-completion handler, but this handler is not visible in your code. Yeah? To you, the code just looks like as if it suspends at that point where you call await, and then it's going to be resumed once the future is completed, or if the future failed, you get an exception, right? But it's really about suspension, right, in a non-blocking way. And again, we use the most efficient way to do this. So you really don't have to worry about using await too much, right? There's no too much. The only thing you can do is maybe reduce the amount of parallelism in your code, right? But that's possible always. But await doesn't really do any harm, right? So how do we use this? Well, let's say we have a bunch of futures here. And again, these are actually just regular Scala futures. And again, most of the time you probably get futures from, calling into some API, let's say, of like the Play framework or Akka or some other framework. So you got your futures here. And well, what you can do is inside your async block, you can simply await the completion of a future here. And it looks like a blocking call, essentially, right? Because what you do is you suspend the execution until you have a result. And that's just a plain int here, right? Nothing special about answer. So you really you automatically suspend within this async block. Yeah? And await is really just a normal expression, so you can use it anywhere you want, right? You can use it as just like a normal method. Okay? There are a couple of restrictions where you can't use await, so I'm going to talk about those later, but there's not very many restrictions. So in short, all you need to know is really these two method signatures, right? So async basically takes a body or a block of code, and now this block of code, of course, we don't want to evaluate on the calling thread, right? That would defeat the whole purpose of doing asynchronous execution. So what we need to do is we need to delay the evaluation, and in Scala we do this using by name parameters. So this leading arrow indicates that this is a by name parameter. So it's not going to be evaluated before actually calling the method or evaluating the method. That's going to be executed in the execution context that's in scope. So I haven't shown you any other implicit parameters that are there, because typically you don't need to see them or use them, right? And so the result is a future of t if the body evaluates to a t. And then await is just dual, right? It takes a future of t and returns a t, right? And if you look at await, it really looks like old school, synchronous blocking thing, but it's can't believe that this doesn't do any of this evil blocking. So it's really good for you. It tastes good. The question is, of course, do we need this? Do we really need this? And I mentioned in the beginning that I believe we definitely need this. But I just want to show you a couple examples, right? I'm sure many of you are well-versed functional programmers that write maps and flat maps every day. I do too, but I still want to explain this example. Basically, what we do is, again, we obtain a bunch of futures. In this case, we use play, and don't worry about the API, like what response is and things like this. All we care about are these futures. And now in Scala, we have all these higher order functions like flat map and map defined on futures. And we can basically use those to transform a future into a new one. So this future day of year, we can transform into a new future that completes once this future completes and the whole body of the closure is executed. So what we do is, so basically this closure runs as soon as this future is completed, right? And then we have this response, and we can look at the body, and then we also want to know the result of this future. So again, we call map on it, which returns a new future, which completes once that one completes, and the closure has been evaluated to a result. That's then the result of the result future of map, right? And the result future of map is then used to complete the result future of flat map, okay? But sort of the bottom line is we want to know both results, and as soon as we have them, we can produce a response, okay? So, you know, it's pretty natural for FP people, but with async, it's actually much simpler, because what do we have to do? Well, we just wait for the first future. That's a response. We look at the body, wait for the second future, look at the body, and produce the result, right? So you can explain this in 2 sentences or maybe even less, whereas this one, you need to explain, okay, well, we have a closure, and we pass it to flat map, that returns a new future, and that's completed when this happens and that happens, right? So, you know, arguably that's simpler. Of course, in Scala, if you know Scala, you know that there are also for comprehensions. And those you can actually use with futures as well. And you can write more sort of straight line code using for comprehensions. So let's have a look at how that would look like. And indeed, it looks pretty nice. So what you can do is essentially, in this for comprehension, you use generators, right? The first generator says, okay, well, once that future completes, give me the response in this variable. And you know, same for the second future, and then we can yield our response. And the overall result of this for yield is, again, a future, just like in this, well, just like in both examples before, right? We always get back a future. Now, this looks pretty okay, except that we have to write for, which is kind of, for futures, it's not so natural. But it's, you know, it's pretty well. The only minor annoyance is that we have to introduce this intermediate results, DOI response, for example, right, in this other one. And, you know, introducing temporaries is not such a big deal, although it does have a noticeable impact on your maintainability of the code, right? If you're interested in this, I encourage you to look at Martin Odersky's Scala Days keynote, where it was all about style, and that essentially temporaries are tricky, because if you introduce them, you should provide a good name for them. If the name is bad, it just confuses the reader, right? And we write code so that it can be read well. So it confuses the reader if the name is bad. So you better spend some effort on this. But then you ideally have a choice whether you want to introduce a temporary or not, so that you can make an informed decision of whether having this intermediate result would help the reader. In this case, we're forced to introduce intermediate results. Yeah, so there's no choice, really. And of course, the names also are very boilerplatey, right? But it's not so bad. So let's have a look at another example. This one's more interesting. Basically, we do similar things, right? We have methods that return futures. Here we have a regular expression. If you're new to Scala or you haven't used regex before, you should definitely have a look. I think it's a really cool Scala library. We can use verbatim strings here, so you don't have to escape all the backslashes that escape other backslashes and so forth. So that's pretty cool. And you can pattern match on these things very nicely. So what we do, maybe I can just explain that first. So we have this regex here, and we can actually match on a string, and then we can match against this date pattern. And these month and day, they will be bound to the contents of the 2 capture groups in the regex, right? So you can directly extract what the capture groups contain. It's a pretty natural way to do this. So, but again, the logic is pretty simple. All we do is we wait for this future, and then the body is a string that we match against the date, and then we only have to call this name of month method and wait for its result. And that's what we put into the string, right? Otherwise, we say not found. So it's actually pretty simple from the logic, and you can clearly understand this. However, if you try to do this using for comprehensions, then it looks like this, right? Where basically, again, we need these generators to look at the futures, and sort of once that completes, we get a response and so forth. We do it for the second one too. And the result here, we have to match against that, same way with the regex. But now the trouble is, once the regex has matched, we need to have the result of a second future. Okay? But the only thing to get at the result of the second future is using another for comprehension. Okay, so we need to create a nested for comprehension just to be able to look at the result of this guy, right? The result of name of month. And then we yield a response. Now, the problem is the for yield returns a future because our generator reads from a future, okay? But that means in the other case, we also have to provide a future. And of course, that's going to be a future that's already completed because we know the result already. And so this introduces all kinds of complexities, right? So we have basically a whole list of annoyances, right? We have to name temporary results. We absolutely are forced to do this. Then we have to use these nested for comprehensions, which not everyone is so comfortable with, right? And then we have to realize, oh, this guy actually returns a future. Does that even work? I mean, like this code is it took Jason and me like 15 minutes to come up with the correct version of this, and whereas the code before you can write down from beginning to end like in 10 seconds, right? Because you just directly express what you have to do, right? Whereas here you have to know how for comprehensions interact with the future API, map and flat map and so forth. Okay, so I think that's a good example that shows that this can really help in practice. And if you look at production systems that I've been doing a few times, you have people have they use futures and they chain them together in 15 to 20 steps, right? All using map and flat map and filter and so forth. And you can imagine, in this case, we only have essentially, one flat map, one map, and another map, right? But imagine, so these are only 3 of those combinators. Imagine you have 15 to 20 of those, how this would look like, right? So, yeah. So this direct style, basically, so this is what we call direct style. Expressing things like this, basically in this sort of blocking style, right? What it provides you is that you don't have to, it doesn't force you to introduce names for everything, right? That's the first thing, and it does help in practice. I'm losing my mic. Oops. Sorry about that. Okay. Good. And the other thing is this direct style really allows you to express the control flow quite naturally, right? And the reason is that with await, we can essentially suspend virtually anywhere, not really, but virtually anywhere in our Scala expression, right? Within if else, while, match, try, catch, just in between, we just can wait. We can await a future whenever we want to. Whereas if we use for comprehensions or something else, we always have to somehow fit things into this other style, right? So if you just want to express a control flow, that makes things awkward, right? To use for. And also map and flat map. It's really map and flat map, I think, are best for if you transform data, right? Or streams, if you want, right? For Rx, for example, makes a lot of sense. Or collections, right? Map and flat map. But if you talk about futures, where it's really mostly about control flow and suspension, resumption, and so forth, I think it's much less natural to use these sorts of combinators. Okay? So now, of course, there are a couple of things you have to keep in mind if you use await. It has to occur within a directly closing async. Well, if there's no async around it, you get an error message, which is pretty readable in our case. That's good. But you can't use await within a closure, right? So if you have an async block, and actually I'm going to show you an example. But if you have if there's an async block and between the async and the await is a closure, that's not going to work. Okay, and that's similar for local functions, classes, objects within async, right? In Scala, everything can be nested, right? You can have a locally defined object or function, right, within an async block, no problem. But you can't use await within those things. I mean, those are arguably not that common anyway, so we don't think it's a big restriction. Also, if you have an argument to a by name parameter, you won't be able to call await within that argument, because by name actually, translates to generating a closure. So we end up with the first problem. But here's an example, and it also shows you how you can get around this restriction. And here we can actually piggyback on the work we did for futures. Basically, the idea is this, right? So let's say we have an async block, and we find ourselves in a situation where we do have a closure that we pass to map in this case on a list. That's a well-behaved map, so you should do that. But right, so you have a closure, and within the closure, we'd just like to await a future. Yeah, and then of course our macro is going to say, well, look, you can't do this. So what do? Well, actually, the simplest thing to do, at least in this case, and in many cases, is to just wrap your expression that contains the await in an async, right? And now that, of course, is going to return a future, which means if you map a future returning closure over this list, well, then you get back a list of futures, which was not your original goal, right? The result of this list is just a single list map is just a single list that you want to put into a future. But now we suddenly get back a list of futures, right? And but now to transform this list of futures into a future of a list, we can just use this combinator, future.sequence, and this future companion object has a bunch of those combinators to work with collections of futures, right? And so, that's a pretty simple way to resolve this issue, right? And so basically, this existing, fairly rich API for programming with futures, we can just piggyback on that. Yeah? And so these restrictions that we have on like the usage of await, they don't feel that constraining in the end, right? So now let's talk a little bit about future things. Basically, there are a couple of interesting developments. One thing is sort of how do we debug these things well? And well, one thing is that if you have async and await, a couple of await calls, then your code is going to be chunked up essentially by the macro into pieces of code that run as tasks in a thread pool. So of course, parts of the code run on different threads essentially, right, within your async block, and so you can't just like step through it sequentially. But what we've been doing is basically provide a mechanism that with a simple import you can just enable sequential debugging, which means async blocks are executed sequentially on one thread, where basically all the awaits now become blocking, truly blocking. So the current thread will wait until the future, that's the argument of await, comes back. Of course, that you only want to use while in debug mode when you want to step through things, right? But the good thing is that the stack of the thread executing the async block remains intact throughout the whole async block, right? So that's a pretty neat thing. The other thing I wanted to talk about has to do actually with reactive extensions. And Donna and Matt, they already mentioned that there's actually a lot of activity with reactive extensions in the Java world with like Netflix's effort. And they're actually also working on Scala bindings, and there's lots of development going on in this space. And turns out that you can actually connect async pretty nicely also to observable streams. So for those of you who haven't been at the previous talk, I just want to quickly sort of recap what observables are, which are basically at the core of the reactive extensions model. Basically, we need two traits in Scala. In Java, you would have interfaces here, right? So basically, we need an observable, but that's sort of the main trait, right? Observable is something that can produce events. What you can do is you can essentially subscribe to that observable if you want to observe it, right? So you subscribe to it with an observer, and the observer then consumes all these events that come from the observable. And what you get back as a result of subscribing is a closable, or it could be a subscription or something like this, that you can then close if you're no longer interested, right? So you can do some cleanup, deregister the handler under the hood, the handlers under the hood, and so forth. So the observer then is simply a trait that it needs, at the least, it needs three methods. Essentially onNext, which is a method that would be invoked when an observable produces the next regular event of type T. Yeah? The other method you need is you need to be able to respond to failures. I mean, you don't have to, but that's one possible event that the observable can emit, essentially failure with some throwable. And the third event is done, which is emitted when the observable is done emitting events. Yeah? So some streams are infinite. They never emit on done. Yeah? But in general, they can also terminate or stop producing new events. Okay? What I added here is some other things that are not so essential, but we can extend function in Scala, right? A function from try to unit. Try is a very neat container for sort of heap-based exception handling as opposed to stack-based, like try-catch-based exception handling. So if you haven't seen that, have a look. It's used also in futures. But basically, you can just use it to essentially make it more convenient to implement observers, right? We just have to implement apply and onDone in this case. But it's not so essential, right? So with these two interfaces, you can do a lot of things, right? You can build all kinds of combinators that can, create observers, observables, and so forth. But with async, the cool thing is we can, with a small extension that right now is experimental, right? So we can actually consume those observables in a very convenient way. So basically, what we can do is, instead of writing async here, we write RASYNC. Okay, so reactive async, and the idea is that this thing returns an observable instead of a future. Yeah, so instead of just having something like a future that has a single result, we can have it produce or create an observable that can emit many events. And then the next thing we introduce is this await next or done, where basically you pass in an observable, and you have this non-blocking way of waiting for the next event, if there is one, or done, if the stream emits done, if there are no more events, right? And then basically you can get back an option, which in Scala you have two possibilities, right? None and some of some value, or none if the option is empty. So none would mean the stream has emitted done, right? It doesn't publish any more events. Yeah, but it's very similar to await, except that you await the next event. And then you can, so that's how you can consume streams. And of course, you can consume as many observables within your RASync as you want. But then you can also yield events. So this we can do with yield next, where basically, you just yield the next event of the current observable. So the current observable is the one that you're constructing with this RASync block, right? So this RASync so you can essentially produce many events, and they're basically, they're produced asynchronously, and there can be arbitrary many observers subscribe to this forwarder, and so forth, right? But this basically gives you a way to create and consume observables in a very natural style, right? Where you don't have to use combinators that that you're maybe not so familiar with. Like here, you can really write straight line code to do this. This is also called array, just because of the constructs, RASYNC, await, yield, and so forth. But this is just an experimental thing. We've written a paper about this. So if you Google, or I'm sure you can find it somehow. But again, like what I also want to point out is that this is possible because async is a macro, so we can pretty easily play with it and like come up with variations and things like this, right? And again, like if you want to play with this, you're very welcome. It's all on GitHub, and it's open source, so it's a really nice thing to play with. Okay, so let's conclude here. So the async macro, again, I think it really does a lot of hard work for you, and it's exactly the kind of work that, in my opinion, other frameworks don't really do, right? They promise you, oh, your life will be so much easier with this awesome futures library or that awesome actors library or some other. I mean, there are, of course, very deep facilities that some of these frameworks provide, like Akka, for example, or other frameworks like this, right? That you wouldn't get in any other way. But sort of async does sort of this other aspect, which is sort of complementary, which says, well, sort of how can we do this basic mechanism of like suspending and resuming, right? And how to do this in a non-blocking way, right? So the generated code is really efficient, so you don't have to worry at all about what comes out. I mean, you can, and it's quite cool because the generated code is pretty easy to understand because what it spits out is a very simple state machine. Of course, the code is going to be much longer than the original code that you've written, but it's actually pretty easy to understand what comes out. It just generates one class for your async block, which is a state machine, that you can resume or suspend and resume and so forth, right? You can like say, okay, start from state 4, right? And the current values of the results are stored in the fields of the state machine and so forth. It's rather simple what comes out. And we can make it efficient too. So for example, boxing of intermediate results, we can avoid pretty easily. And if you would like do this while creating continuation closures, then that would, for example, be harder to do. So now, what is this useful for? There's lots of places, of course, where we can use it out of the box. For example, Play, right? Play uses futures a lot, the zip14. Async is it's a perfect fit for this. All you need to do is add the async jar to your class path, and you can use it, right? And similar for Akka, right? Akka integrates actors and futures pretty nicely, and there, again, if you want to wait for your futures, you can use async await. What would be really cool is if one of the high-performance I/O libraries for Scala would make use of that. I'm still waiting for this to happen. This would be, I think, a pretty good fit as well. Some uses of delimited continuations can actually be done with async await. And it's totally possible also to connect it to other asynchronous APIs. It doesn't have to be futures. I've shown you RX, but you can do other things as well. We have a few extension points in there that you can use. So the takeaway, again, like these two method signatures, pretty easy. Async, create a future, await, you wait for a future, and looks like it's blocking, but it can promise you it's not. And so what I have right now is essentially we have a pretty stable implementation for both Scala 2.10 and Scala 2.11. So that means actually you can try it today, right? There's nothing that prevents you from using it. And it's on GitHub, and you know, same license as Scala, which is nowadays BSD. So, and we've also written a Scala improvement proposal, so that because we sort of what we'd like to have is to have this as a new module of the Scala distribution. Yeah. And so here's a plug before I end. There's a new MOOC, which stands for Massive Open Online Course on reactive programming, featuring Martin Odersky, who's going to give a keynote tomorrow, Eric Meyer of reactive extensions fame, and others, Donna's former boss, as far as I know, and also Roland Kuhn, who's Akka tech lead at Typesafe. And so these people are going to talk about essentially reactive programming abstractions like futures, actors, reactive extensions, observable streams, and so forth, and also like how to program with state and monads and so forth. And actually, Eric Meyer really wants to use async as well. So that's really exciting because we can sort of simplify a lot of people's lives and make it easier to complete the homeworks. So that's pretty cool. And the course in general, I think it's highly recommended. And you can even get tutoring, personal tutoring from Typesafe as well. Yeah, so Q&A. I don't know if you have still time. A couple minutes, so if there's questions, please, feel free. Yeah? Are you referring to performance, or? Yeah, so performance evaluations compared to other techniques or other approaches or libraries. We haven't really done that yet. So we only can say sort of like the closest comparison that we have right now is using the continuation passing style plugin from Scala, right? And there we should run some experiments to see how it fares. But the only thing that we can say for sure is that in Scala Async, we don't create as many closures, whereas with CPS, at each suspension point, you create a new closure, which has some impact. I mentioned the boxing, which could be different, but yeah, we haven't really done a lot of performance benchmarking, but we definitely want to do that, should do that, and because I'm actually quite confident that this is going to be faster than many other things. Any other? Yeah?
In your SIP, do you think this properly stays a macro, or would this be better as a language feature? Can you talk a little bit about
Okay. So the question is in this Scala improvement proposal, do we intend this to stay a macro, or would this be better built into the language, right? And I think the answer is it should stay a macro, if at all possible, because it's it has a lot of benefits in terms of sort of packaging. You can decouple development and maintenance from the mainline this compiler, right? So it has all these sort of advantages, and building it into the language as a separate phase in the compiler, it wouldn't actually help that much, we think, right? So, yeah, we haven't seen it. We haven't seen anything that would help us if we would integrate it. So, okay, thanks.